Finite state machines with outputs. We have two different types of finite state machines with outputs. The first one is the Moore machines, the second one is the Mealy machines. The difference between the two is in the Moore machine, the output is associated with each state, whereas in Mealy machines, the output are associated with each transitions. Let's take up one example and we'll see how to construct a Mealy machine as well as a Moore machine. The first one, construct a Mealy machine accepting the language consisting of the strings from the alphabet, where the alphabet defined over two symbols A, B, and string should be with either AA or BB. So we need to come up with the Mealy machines. Since the Mealy machines, the outputs are associated with the transitions, we should check whenever we have a string with AA or BB, it should always output as 1. In all other cases, we'll consider to output as 0. Fine. As soon as we see a string, any string with AA or BB, immediately it has to output 1. In all of the cases, it has to output 0. So we need to construct a Mealy machine that is accepting all the strings with either AA or BB. The thing is, whenever we see AA, we'll output 1, or BB, immediately we'll output 1, and in all the cases will output as what? 0. So the first thing is, let's start with the state Q0, initial state. So we should have a substring that is AA or BB. So here, so when we see A, let's go to one more state. I'll consider this state as Q1. Now after this, in this state, let's read one more state character A. So when we read AA, we have two A's here. As soon as we see two A's, immediately it has to output 1. Right? Why we are providing the output along with the transitions? We are constructing a Mealy machines. Now when we see only one A, it should output 0. When it reads two A's, so AA, it has to output 1. In a similar way, let's do it for BB. So initially, from the start state, as soon as you see B, it should always output as what? 0. When we read two B's, it should output as what? 1. So only one B, 0. When you read two B's, BB, it has to output as 1. Now immediately after this, since it is a finite state machine, so it should accept all the strings which has either AA or BB. It is not just only AA or BB. Correct? Now when we have A, again A, or if you just take an example of ABB, fine. So if you take an example of ABB, start from what? The start state. On reading A, it is outputting 0. Now from this state, it has to read what? The next symbol, that is B. So we'll just, this is since it is a valid string, so we'll see that even these types of strings are accepted by this deterministic finite state machines. So what we'll do is, we'll have a transition here, fine, on B, fine. So here we are reading a single B. So on reading a single B, output 0. Now come to this states. So again we have B here. So immediately we are reading two B's. The next B is read. So from Q2 on B to Q2, finally output as what? That is 1. Right? In a similar way, if you just take an example, something like A, okay, BB followed by A. Now from the start state, read the first character, or the, okay, so from Q0 we are going to state Q2. Then once again, since we are reading only one B, it is outputting 0. Correct? Now once again, when it comes here to Q0, correct, for Q2, again we are reading one more thing, so it is outputting 1. Now coming to A, so there is no transition that is happening on A, so this is an invalid string. Now suppose if I just consider one more A, so as soon as we read two B's, it has to output 1. Again A, it has to output as what? 1. So here from Q0 on B, then again from Q2 again on B, so two B's, immediately output 1 for this occurrence of the string. Then once again from Q2, there is no transition happening on which character, that is A. So what we'll do is, we'll have one more transition from here, okay, on A. Okay, since from Q2 we are reading only one A, so here the output is 0. Then again on reading A, it is in state Q1. on A, okay, so we have an occurrence of A, immediately it has to output 1. So again read A, immediately it is going to output 1. Fine. Now this is a Mealy machine that is going to accept all the strings with either what A or BB, and immediately as soon as it reads A or BB, it is going to output for this occurrence as what 1, in all other cases as 0. Fine. So these types of machines where the output are associated with the transitions, they are called as what? Mealy machines. Let's take one more example and we'll see how the Mealy machines are different from the Moore machines. The problem is, construct a Moore machine that counts the occurrences of the sequence ABB in any input strings over AB. So the alphabet is defined over 2 symbols, that is AB. So whatever the string we are going to consider, suppose W, this string must have a substring, the substring AB, B, again A, B, B, fine. As soon as it sees the occurrences of this substring, your Moore machine has to output as what? 1, again what? As 1. Fine. In all other cases, when it start reading the symbols, it is going to output as what? 0. Fine. And in Moore machines, the output are associated along with the states, not with the transition. Now, before we convert a finite state machine to the Moore machine, let's come up with a finite state machine that accepts all the strings with the sequence ABB. Fine. So we should always have a string with what? ABB, and before this it can have any number of A's, any number of B's, or followed by this can have any number of A's and any number of B's. So whatever the string you consider, it must have, for a valid string, it must always have a sequence that is ABB. So as soon as it sees a sequence ABB, output as what? 1. In all other cases, it should output as 0. Now immediately, so let's start with the state Q0. Fine. So first I'll come up with a finite state machine to accept this particular substring, that is ABB. So from Q0 on A, just go to state Q1. Now from Q1 on B, we'll go to one more state Q2. Again from Q2 on B, we'll go to state Q3. Fine. Now after doing this, fine, so ABB is accepting. Now before this, okay, we can have n number of A's, fine, then that is followed by again ABB. So here what we'll do, we'll take, okay, A, so it is nothing but we can have A, then BB. Can you check whether it is happening here? A, 3 A's and 4, then A, B, B. So it is taking this particular string. Again, if I consider here, again we can have here what? On A. So any number of A's, start with this, any number of A's, finally have a substring. What is the string now? That is A, B, B. Fine. Then after that, we have a transition from here to B, here to B. So from here, there is no transition on A. From here, there is no transition on A. From Q0, again, there is no transition happening on where now? On A. So we need to come up with what? This transition here. So again, what we'll do is from here, okay, again, let's have one more transition on which symbol now? That is on A. Again, from here, let's have one more transition on which symbol now? On, that is A. Fine. So we can have a transition on A. Again here, sorry, this one you can consider as B here. Fine. So we can start with, can have any number of B's or A, or any number of A's, then B, B. So finally having with ABB. So this is a finite state machine for all the strings having the sequence that is ABB. Now as soon as you see ABB, the state of the machine has to output as what? 1. Correct. Now from coming to this state Q2, fine. So since it is accepting only B's and A's, not the sequence, that is A, B, B. So here what we'll be doing? So it is going to output what? 0. So this state is going to output what? 0. Again this state it is going to output what? 0. Again this state it is going to output what? 0. And finally this state it is going to output what? That is 1. Fine. So in this state it is going to output 1. This is 0, this is 0, this is 0. So as soon as you reach state Q0 and read any symbol, it is going to output as 0. But when it sees what? A, B, B, fine. So again here you can see A, B, B, or A, B, B. Finally always we will having some sequence. So as soon as it sees the sequence that is A, B, B, it is going to output as what? 1. Right. So here the output are associated with the states. So hence these types of machines they are called as mode machine. And this is the difference between Amelia machines and mode machines.